Welcome once again to Lyrical City, where the GLMs run and the shops are thrifty, in the holiday spirit with prices so low, trying to predict how people will come up and show. Using MRC, we can make predictions of continuous variables and what will happen, and ANOVA too, with categorical factors, find the difference between them and their interaction. See, all of it's part of the GLM. Though assumptions abound, there's a little less than 10. We'll break those down later as we go through, because the GLM is a versatile too. A simple equation, y equals BO, that's predicted value of y when x is 0, that's the intercept. Then we add b, the slope of our model, which helps you multiplies you see with the ever-changing x, a continuous IV, then add in the error represented by e, because always in our measurements we assume error and try to account for variance so we minimize terror, because at least in MRC, where Aristotle plays the errors in our model with residual ways. In MRC we take a look at our plot and see what kind of data we got. Then based on our predictions we try to find the smallest difference from the points of the line, a best fit that we draw through it all to give us least squared residuals that we can call upon to find the significance of our predictions, and if we don't square them, what we find is 0, and if that assumption's not met, then we'll find some bigger problems yet. But if it's okay and our data's collected right, then our model might work and make Christmas bright for the stores and the customers, shoppers alike. So let's get into the nitty-gritty data. So we take our data and standardize, convert to z-score units, and remove units live to see the impact of our 4 IVs on the tendency to go on shopping sprees. See, in value x1 we've got charitable index, and x2 we've got hairband purchases, in x3 we've got giving tendency, and x4 describes caffeine dependency. And if this all plays out like we hope, we define with rectilinear predictions a solid line that trends well with some explainable variance. Let's run the data and keep from tearing. And what? Oh no, the slope is terrible. None of the predictors work. It's so unbearable. But wait, while we know that the GLM's robust, there are major problems if we violate assumptions. What could be happening is an error type 2. So let's test assumptions like Artina, who demonstrates the problem most clearly of having two predictors with high collinearity. Now we could test this problem with a correlation, let's instead break it down with variance inflation factor, an actor which shows how related our variables are, and as they grow, the p-value shrinks with variance split amongst our predictors and makes us sit and think about removing one of our predictors to strengthen the others and make our model better. So we do just that, and big surprises, our model's x1 significance rises. So maybe we can reject the null, say our x1 is significant, and that is all. But Gary King says no as he rides on by, telling us about other assumptions we have violated. Just hated. I don't want to restate it, but our other x's, while not correlated, violate basic statistical assumptions, and even the standardization by gumption does not allow the comparison here of hairband sales and coffee fakirs. What's more, our data is still out of whack. This residual fitted plot might mean heteroscedasticity. You're killing me. You know this is bad. If our model can't describe the data, no one will be glad. But wait, because we know this misaligned spline is most affected by data points out of line. What's worse, this might mean a non-zero correlation of predictors and residuals. Oh, the suffering nation of Lyrical City has such devastating assumptions. How are we going to go on with this function? Which leads us next to a test for normality in this quartile plot against standardality of residuals. And we might have some problems going on as the deviation of the line seems pretty strong. But look, aha, the residuals unlevered. Thank you, Beck and Beck, because what that means is we have a data point both describing from the rest and significantly different, giving it leverage and above and beyond the rest of our data. See, it's beyond scope distance, and we gotta hate ya, because this point ends up skewing our data set, and deleting it might cause significance yet, but that leads into an ethical quagmire about keeping data even when it's an outlier. Sure, its removal might make it homoscedastic, give us normal residuals, and make it fantastic, but it also might be a real difference, an extreme case which, while it might hinder us here, demonstrates a unique example like pathology or error sampling that exists beyond the sample. And if we were to remove it, where would it end? Deleting data points against the ones we penned, chasing high R's, though King doth show that high R's don't mean significance mo. So instead we come to a different solution, presenting both data with and without them, the outliers that is, thus allowing reviewers to assess our conclusions from perspectives newer, or maybe go back to the drawing board, remove uncorrelated data that hordes variance away from the rest of the points, and with better predictors we can rejoice. But I'm tired of this, so I'll move right along to the other half of GLM in this song, and much like MRC, it shares the assumptions of homoscedastic data and residual normalization, not to mention correct data collection and contiguous variable selection, but it's also got a few other assumptions and features like veracity and orthogonal nested variables. See, unlike MRC, which uses R, ANOVA uses F, and it takes us far. It's the mean square, that's the between group variance divided by residual, so it won't harass. See, the residual is just the variance within groups, so the ratio we got when we divide the two is F, or T squared, though there's a few other ways to find the value, but we've seen better days, and while we can easily convert from R to T, and the T to the F, and the F to the P, the real value of ANOVA can be seen in comparison of multivariables between, though unlike MRC, these variables categorical lead to nested models, quite historical, and necessitate each factor level treated is expressed in all other factors needed. In violation of this spherical assumption leads to type 2 errors with no luncheon. So let's take another look at data we have of holiday spending and categoricals glad. Thankfully we did an interocular test of nested variables, so we know they're the best. And like MRC, ANOVA has an intercept, though here we call it mean and compare it to the next, and we see in this test how the F ratio significance at the 0.05 level. Getting it? For the value dub is musical vocation, but the same can't be said for religious affiliation, nor is the interaction statistically significant, but that's just fine because we don't need to post hoc it, though really post hoc is only needed if we had more variables and want to tease it apart when the levels exceed 2, but some assumptions can be checked. Oh, boo. For example, we had to check variance homogeneity, the assumption that our group's variance is the same, because if this assumption is imposed and one group's S squared much larger grows beyond the scale of our sample, then type 1 errors occur by the handful. And with our good friend Levine, we failed to reject, so on the homogeneous front, we're good yet, and when we test our residuals against our model, we see little devastation, so residual independence, we gotta. But just like MRC, we see QQ plots different from the line, might mean normality not, and that's sad, as they say the module's robust, but it'll strain if we violate too many assumptions. And as we plot a squared standardized residuals, we see some distance from the middles, especially in the upper end. And while some heteroscedasty pretends that is more like the influence of an outlier seen in residuals and leverage the next one over. And like before, while we may have some impaction, it shouldn't be too bad, just a bit of distraction, though these influences are minor. And I'd like to say the musicians are more cheerful on Christmas Day, nor to reject the null and say, well, religion not fine, nor is the interaction much online, but we have at least some significant effect. But unfortunately, I must confess that this was not the first hypothesis run here. We had too much haste for this time of year, and that its significance can only be said to be accurate when p is less than 0.001, dagnabbit. And thus I say I failed to reject the null, and with a better theoretical framework we could pull this data out first and say it was true, but we did not, and so we say, Pearl. And I thank you for your time and the knowledge you gave, the readings we did, and the labs that we played. Before we go and climb Everest, I hope you'll come back, because we'll never rest, learning up stats and make research better be, and for the last time I submit, I am the chillest of